All right, let's continue. Thank you again for joining to the last day, day 4 of Video Foundation course. Today is the fourth day of the training, and if you have any clarifications based on whatever you have learned up till this point after your review on the past recording or based on the quiz, if you have any questions, you can post it. We can discuss, we can clarify. All right. So what we learned last day, that is the third day, was about analytics, how analytics help the operator, the end user, who is invested in the CCTV to gain more from the camera. So analytics allow the camera to detect any uh, events, unwanted events or intrusion events, motion events, any security related incidents or accidents it can detect and can alert the operator, right? So it's like you have eyes and you also have that particular camera alerting you based on what it sees, right? So this is quite helpful. There are different levels, different ways of doing analytics, the traditional method and the um, artificial intelligence method. Also, there is one more point. There are two types of analytics implementation, on the edge or on the server. On the edge means the analytics is on the camera itself. So customer is purchasing the camera, the analytics are included. Some brands, you will purchase the camera and you will pay for the analytics additionally. If you want, you can pay extra. So that is one other option. Maybe the analytics is developed by someone else. So when you pay for it, they will install that analytics on the camera. Uh, there are vendors. For us, we have both options where you can find any third-party analytics. You can also install on the camera, or we have all the analytics that we talked about yesterday. They're all built-in analytics freely included in the camera and works with any of the reputed VMS or our VMS or our NVR. Okay, so server-based analytics versus edge-based. Server-based means the camera only sends video, then the server has to process the image once again for uh, analytics. Now, what is the challenge in server-based analytics? You need more server footprint, right? You have to purchase more servers to do processing of this image once again to extract metadata to do analytics. But that's like the old school method. Today, edge based is the most efficient method because you reduce the amount of hardware required. Not only that, server based analytics are always license based. You will pay for servers plus the license, camera license, analytic license, and then recurring license, supporting license, and all that. But generally, most of the security analytics, it is best if it is inside the camera. There are maybe some special analytics which can be server based. It could be like facial recognition, or it could be flame detection, or even those today are coming towards the edge. All right, so even those heavy processor based analytics are coming towards edge. So having said that, uh, you can choose, you can make the right choice. Um, First, what you have to check is, can I do it on the edge itself? If that's the case, well and good. Only then, if you are not able to achieve it on the edge, then you can look at server-based analytics. All right. So we saw about enter exit. So we explained the, all right, one second. Just a second, please. if there is a machine moving, yeah, if there is a machine moving, it will not detect as a motion. In AI-based analytics, it only focuses on what the camera has been trained to understand, as in the camera has been trained to detect a human being, camera has been trained to identify a vehicle from the picture, and based on that, it takes a decision, right? So here, in this case, we saw unnecessary alarms due to change of light, rain, uh, maybe cats and dogs moving, animals moving. The camera will not trigger an alarm. It will only look for human being. So having said that, you can do the same line crossing, and you can uncheck or check what kind of uh, you know object you want to detect and raise an alarm. So let's say the public surveillance, they want to monitor the street if someone is crossing the street, right? If they do the traditional analytics, okay, they do the traditional analytics, and if they say if someone is crossing the highway, that's like that can, I mean, it's it can lead to an accident. So they want to detect and trigger an alarm if someone is crossing the highway. So if they do object size, the car is always bigger than the human being. So for sure, it will always create an alarm. So AI is actually the only option in these kind of situation where it can probably and more accurately pick up in a highway where lots of cars are moving. If there is a person, it will pick it up and tell you, all right, there is a person in this zone and he's in the road, maybe blocking the highway. So that can be triggered as an event. So in this video, you will see there is a human being here. There is a cars here. It clearly distinguishes. Uh, you can see by the color of the bounding box, it's blue and yellow. So it knows what's the difference. And also with artificial intelligence, using deep learning, okay, deep learning, it is quite capable of even picking up the object behind the, behind the tree or any obstacles. So that's quite useful because even if a person is hiding behind the tree and maybe you only see half the human being, the camera can still pick it up and say, all right, I see a person hiding, right? So that is good. Now, if whenever you're using artificial intelligence cameras, higher the resolution, very good, because you will get more details. You can see more. Uh, Basically, you can get more data from the scene, and it is good for the camera with AI. So you can cover larger distances. All right. Now, in artificial intelligence, the camera also picks up attributes from the scene. It saw the car, but what kind of car? It's a saloon car. What is the color of the car? Human being, what is the color of his shirt? What color of his pant? So it picks up all this extra data as well, which will help you in doing forensic search. Quickly identify, I'm looking for a person between a certain age group wearing this shirt, wearing this, carrying a bag, wearing a glass. So it helps you to quickly do incident search faster, right? Instead of playing the video for last 24 hours and then trying to pinpoint where the person is. And also you get visuals, right? It's not text. You just get visuals and you can directly click on that photo, find similar photos, or you can save that particular photo as a bookmark and look for him later on. Things like that can be done. So here it is, and right side you can play the video. Now AI, you should not limit it to what is already available. It can be extended. The benefit of AI is it's scalable. You can use according to your project requirement. Certain projects you can say there is a it's a road traffic for only trucks, and if there is a car, you can create an alarm. right? You can identify when car was seen. You can search when all cars were seen, and you can probably take some action. Similarly, you can say only school buses allowed. So if there is any other bus with a different color painting, you can take a trigger, you can take a call. So there are different ways how the end user can use artificial intelligence. All right, it's not limited to what we are providing or what we are informing you about. So the application is up to the end user. Then we saw ONVIF, Open Network Video Interface Forum. Actually, the full form, most of them may not really recollect, but ONVIF, people know, everybody knows about ONVIF in the CCTV industry. If you don't know it, you must know about it. It is the open protocol standard for intercommunication from CCTV to any basically within the CCTV, different brands, across different brands. Recorder from a brand A, camera from brand B, maybe there are certain analytics they will not develop specific to one company. They will only take ONVIF video because according to ONVIF, guaranteed is video. So maybe some analytic company will needs only video. So they can work with any ONVIF camera. So this is how it helps ONVIF helps in the CCTV market. Also, the end user has the flexibility to uh, use any camera of his choice or use any VMS of his choice. There are different profiles for ONVIF, and the most important one is the first one. All right, we saw how to check ONVIF on the website. We also talked about cyber security. When it comes to cybersecurity, you will see in the website of a vendor there is something called hardening document, hardening guide. Let me see if I have it here. Okay, yeah, it's okay. Analytics will not have any bandwidth issues. No, it will not have any bandwidth issues. Okay, all right. So here we are looking at cybersecurity document. You will find such documents in vendor website called Network Hardening Guide. Okay. Okay. So in the Network Hardening Guide, there is a definition of security level, default level, then secure level, very secure level. So from this document, you can get an idea by default, there are certain settings enabled. Uh, Telnet, SSH services are disabled, firmware encryption is enabled, um, secure boot is enabled, guest login is not set, it is disabled. So certain things are already pre-configured to have the first level of security. Then you have a secure level where you can change from, uh, for example, instead of using HTTP, you can use HTTPS. On you can apply your own certificate. You can disable SNMP, or you can use version 3 of SNMP, which is more secure. So there are certain suggestions. One of the highest, very secure level is using authentication 802.1. Again, all this, the more secure you go, you will have to have more people to do the configuration and certain hardware. For this, you may need to have an IT hardware for it. So can increase the cost. So this also you have to keep in mind. Right. So next we did talk about NVR, one VMS. NVR is actually a mini VMS. It has basically database of cameras. It has a recording of the cameras, then recording data of the cameras, and it also has the display ports to connect the cameras, to connect the monitor. Right. If I just want to check if in the WebEx, some of you mentioned there is no sound. Please do check. If you still face, let me know. Okay. All right. Here we go. VMS. VMS is a DB server, recording server, and client machine. What's the difference between an NVR and a VMS? The difference is in the VMS, um, the components that make the video management system, which is the database. Database is what IP address of cameras, username, password of cameras, event logs of cameras, and credentials, right? All these data, logs, everything is saved in the database. That is kept on a separate hardware to, so you can scale it up. Instead of one appliance doing all three functions, you have a dedicated appliance doing only database. You have a dedicated appliance doing recording. Instead of 64 cameras per NVR, you can now do 300 cameras per NVR per recorder, or maybe some uh, support 400, 500 cameras. All right. Next, instead of saying just two monitors from one appliance, if you may buy your own PC, or if you use a separate PC dedicated for operators, you can install graphics card and see two, four, some may support six monitors from one machine. So this is all applicable, right? So with the VMS, just a scaled up version. All right. There is also one more difference. VMS is most of the time Windows based. Okay, there are Linux based VMS, but it's mostly Windows based today. NVR recorders, right? These are plug and play devices. What you see as NVR, they are plug and play. With Linux, it's pre-installed. All the software, it's already pre-installed. And for the operator, let's say you're the operator, you don't have to install anything. You don't have to check whether it is compatible. You don't have to do any settings such as whether certain Windows settings. You don't have to do anything, right? That's the benefit of NVR. It's easy to configure. It's already pre-installed. All you have to do is click a few buttons, register camera, add cameras, check the recording schedule, and insert hard disk and start recording. If you want redundancy, you just say, I want RAID 5 redundancy, I want failover. It's all click of buttons, right? Whereas in the server based, you probably will have to insert a RAID card. You have to probably install RAID application software. You have slightly little bit IT knowledge is required on us compared to a typical NVR. All right. So Linux used to be popular many years back because IT knowledge was less in those days. And to do failover redundancy was considered a very complicated thing back then. But today it's quite normal. So, and also Windows is more stable today. So you will see most of the VMS is Windows based now. And even if they were Linux, they're all migrating to Windows. Okay. Then Windows-based VMSs allow you to choose what you want. For example, you can make your own server. Maybe you don't have 300 cameras, you have only 150. You can choose the RAM and the processor accordingly for your project. So customizable. And you can reuse. Maybe you don't like a VMS, you can uninstall, use it with some other brand. But in Linux, or proprietary hardwares, you cannot do that. If it is already pre-installed, you cannot just uninstall and install something else. May not be compatible. All right. In the same solution, so I have a question. In the same solution, can I mix NBR and VMS for recording? Meaning some channels configured on NBR and some of them on VMS server. Exactly possible. There are definitely many projects. They will have different branch offices. In the branch offices, it will not make sense for you to buy a server for maybe 20 cameras or even 50 cameras. Buy a server, install all the check everything and all that. Maybe you have 4 cameras and some branches. There you can use NVR. It's all pre-configured, plug and play, quickly finish installation and move to the next site. So you can use NVR as well as you can use server, and in the end you will manage with a single VMS. So that's the job of VMS, is to manage different recorders, Windows recorders, Linux based NVR recorders, and centrally see them together. Plus VMS gives you the benefit of integrating to access control, fire alarm, or an intercom system. So you can also do that. So it's your central management system. Nowadays, VMS has reached the level where it's not very limited in function. For example, even our VMS, I think I can open the VMS function and show you. In CCTV, most of the time seeing is believing. So, and especially features like these, it's sometimes I really want to show it so you are more comfortable to believe. So let it load. I'm trying to do a remote test. Yeah, okay, done. So here, this is my VMS. Okay, I have two things here. First, I have NVRs. These are NVR, XRN, PRN. These are NVR. Then I also have on the same server, I have directly cameras recording. So I have two buttons here, add NVR. Then I have another button here, add cameras. Directly I can record cameras. So maybe the head office has cameras. The rest of them are NVRs on different location. So I can have a merged system, a mix of system as well. Okay. So that option is possible. How do you calculate a pixel per meter? Just okay, I think you asked me yesterday as well. Let me quickly cover this. On the camera webpage, there is a square box. You draw and you get the pixel 836, 300, and so this is how you calculate pixel. All right. Okay, next is we talked about storage. So SAN, DAS, NAS. Most commonly used in CCTV for small projects is DAS, NVR with built-in storage is DAS, server with built-in storage is DAS, server with central storage, network storage connected over fiber networks, and these are all SAN-based storage. They give you same level of direct attached performance as in, as a feeling like it's faster, it's more, it's as if it's a local drive, as if it's your C drive, but it's on the network. So, and also when you have central storage, it's easy to manage. You can go to one location to manage your entire storage. Maybe you have 1 petabyte, 1000 terabytes of storage. So SAN can be useful for large storage application projects. DAS will of course be cheaper and easier to quickly install. SAN requires more network, more people to configure, more expertise. So you choose what's best for the project in the long term. NAS is in between. So there was a season, I would say, before moving to SAN. NAS was also quite common for small medium projects. It was used, and still it is possible. You can also use NAS. And then we talked about VMS. How does a VMS look? A VMS typically will have cameras on the network switch. Then the network switch will have a central core switch. These are just edge switch, core switch. All right. Why there is a core switch when you have only one? Cameras are connected to the switch. It's not actually one switch. If you have 10 floors, you may have five, six switches. All of them at the back end, they go to a central switch. Okay. From this, there is another switch going to different guard room operators, and each of them have a PC. They want to view the cameras. Done. From the same central switch in the data center, there is maybe another switch which will go to the control room, and it will have control room, and it will have PCs and monitors, right? Then from the same switch directly you may connect a recording service, or you may have another switch and connect recording service. And this switch will also connect to third-party system if you want to do integration. All right, so you get the idea. This is a typical IP system schematic. Edge cameras, control room operators, as here, recorders, and workstations. All of them are linked to a central core switch. Okay. Now, here there is one criteria. When you calculate the bandwidth of camera, 100 cameras, let's say live, one second. So live bandwidth live plus recording. Bandwidth from the camera is equal to live traffic, which is your live viewing traffic. This guy on the control room monitor, you're viewing live, right? That is a live traffic. Then from the camera, there is another stream. There is another video profile going to the recorder. So that is called recording traffic. So there are two traffic. Maybe you're recording at a different resolution. Maybe you're recording on a different frame rate, maybe 10 frames. Some of you may record full frame. It's up to you, or the project, or the regulation. But from the camera, there is always two streams as a minimum, you would see live traffic to the control room and recording traffic to the recorders. Now, there may be exceptions where you have only one stream, but I'm not talking about those kind of projects. But generally, for large projects, this is how you have to consider live traffic plus recording traffic. If live and recording is the same resolution, same bandwidth, you can, for the sake of for the sake of future proofing your design, you can still take it as okay, 2 megapixel, let's say 2 Mbps for live plus recording another 2 Mbps. That is good way to consider for your project. Now, it's not always just two. You should always keep some spare. So we say take 25% spare plus 25% spare. All right. So this is how you consider your typical bandwidth. Okay, so one of you asked a question, can I have NVR as well as VMS? Yes, it's possible. You can have NVRs. It can be standard NVR, it can be a server NVR, and you can have a central VMS. Now, The VMS is now your central point of contact, right? The database is lying on this server. What if the server is out, dead, failed, requires maintenance? Then the communication probably just collapse, right? From your client. The clients will not talk directly to the camera. The client, what is client? The operator PC with a monitor, that is a client. So they speak to the manager and or the central server. The central server speaks to the recorder or the cameras and gets the information. So if the database server is the main authentication server is out, because when the client logs in, he has to give his credential to the database. When the database is not there, how will he give his credential? So if this is out, what will happen? Your system or the operators may not see video. So that's why it is good to have a failover server for the database. When you have large projects, good to have failover. What is failover? If one equipment fails, you need another equipment immediately to take up the role. That is failover. All right, failover. Done. If you want recording failover, you can also have recording failover. You can have one more recorder as a standby recorder. If any of the recorder fails, it will fail over to that standby recorder. You don't need one for each because that is very rare that everything will fail. Any one can fail. It's called, what is it called? N plus one failover. N plus one failover. Okay. What is N? In this project, I have 6 recorders. 6 is to 1. If that means out of 6, if any one fails recorders, I can have one standby recorder which will take over all the recording of the camera, right? So total is 7. One of them is standby, waiting for something to fail, and then it will start recording. That is called failover. It is good to keep a ratio of 8 is to 1 or 10 is to 1, 8 or 10 is to 1. Some high-end projects, they keep 4 is to 1. We have seen that also. Some consultants specify this in the document. They say 4 is to 1, right? If nothing is mentioned and you are quoting for a large project, you can assume 500 cameras is to 1. If you have, let's say, 2000 cameras and you have 4 servers, every 500 cameras or 600 cameras, try to keep one standby server, right? So that's a good design. If you want to save cost, you can probably go higher, but just it will have some, it may have some consequence, right? So try to keep in that level for a good security design. All right, so I have a question. Is Hanwha VMS any specified manufacturer for third-party integration? Um, I didn't get that point. As a camera, you can integrate to third party. So here is our VMS. You can add either OnWIF, that's here itself. You can add Hanwha or OnWIF. Similarly, external device. We have integrations with many access control brands. Honeywell, Honeywell Carey, Lenel, Gallagher, Cardax, JCIP 2000, so many brands, UPS, BACnet over SNMP. So we have quite a few integrations, intercom, standalone, command intercom. So you can use this for your purpose. Okay. And in the VMS, okay, good question. So how do you do failover? In failover in the VMS is also quite simple. Uh, you just enable the option here. You have to add, right now I have only one server. You have to add one more server to the project. And then you say enable failover. So you are a failover server. Okay. And restoration priority. This is some vendors have this. You can, let's say, let's go back to this slide. You have 1, 2, 3, 4, 5, 6, right? And you have one standby. Let's say you have one standby. You can give a priority. The standby server cannot handle all 2000 cameras for sure. It can only handle maybe another 300. So how do you decide? You can tell each server what is the high priority cameras which should fail over. So here in server 1, I can specify first 10 cameras maybe. I can say these are high priority. The remaining ones, I can say switch off, do not fail over. So back to the design. So I have 6 servers here. Then let's say I have one standby. Okay, each of these servers have 300 cameras. And you have a standby server. Standby also is the same like one of these servers. It cannot handle 5000 just because it's a standby, not the case. It can only handle up to 300. All right. Then if the server 1 fails, all 300 will transfer here. Okay. What if second one fails? That's it. It cannot take more than that. So this is why it's called n plus 1. You're guaranteeing up to one server can fail and it should completely transfer and start recording here. This is n plus 1. Some vendors have the feature of prioritizing. They and can handle multiple server failover. For example, you can say from server 1, 100 is high priority. Here maybe 50 is high priority. Here another 50 is high priority and so on. So if server 1 fails, it will only take from server 1 100 cameras. If and still there is a balance of 200, right? So if server 2 fails, it will take the remaining 50. So that option is available, but not with all brands. So this you have to specify. But as a basic failover, n plus 1 means any one can fail, either S1 or S2 or S4, and the standby will take over that cameras. All right. Um, Funny question, if standby fails, what happens? Nothing can be done, but standby shouldn't fail in that actually. So anyone can fail from the active servers. These are active servers because they are actively recording and it can standby. It can go to a standby if it failed, right? Okay, so I will also take this opportunity to explain our new different architecture, which is active-active failover. It's something that you will see. Actually, we also have this. Some of them also have this. So it's called active-active. Each server can handle 300 capacity. Okay, let's write capacity here. Each of them, let's say 300. But I am only registering 150 or 200 each. Only 200 each. Let's give 150 for a good example. Okay, 200 each. I can have a standby, or I don't need to have a standby. This is called active-active failover option. You can have a mix of both in any project. All right, active-active. If server 1 fails, server 2 still has a capability of remaining balance 150. So if server 1 fails, then from server 1, it will take over 150 from here. All right. Then what if server 2 fails? If server 2 fails, you have 300 cameras now. Okay. If server 2 fails, you have 300 cameras. Then server 3 and server 4 will take each 150. Server 1 will take 150 and server 2 it will take another 150 because they have a capacity of 300. What if server 3 fails? If server 3 failed, you have total 450 cameras. Okay, so from server 4, it's already having server 2 cameras. This guy will take server 1, 150, and the last one will take S3 150. So this is active active. Till the last man standing, it will try to take over as many cameras as possible. What if server 4 fails? Then you can, in that condition, it's better you keep high priority option. So only the high priority will fail over, the remaining will stay back. All right, or that's why you have high priority, medium priority. So medium priority will fail over last. Okay, so this option is also available uh, for a VMS design. But this is so complicated. People don't really generally propose this uh, because either due to understanding issue or they're afraid something might go wrong or it's not specified. So what is generally specified is N plus 1. Safe and sound, buy one more server and use it as a standby. It is just waiting for someone to fail and then it will record. But the good thing is, even in N plus 1 failover, if you have this feature active active, maybe each server can handle 300. You already have, in the worst case scenario, you have all 300 cameras filled and you need one more camera. When you need just one more, in active standby, you have to buy one separate server just for this camera. But if you have active active, you can put that camera here and it will record as well as it will do failover. So active standby, active active. So just like the previous example where it was 150 each, it will record as well as it can do failover. So active active allows you to use the server for recording as well as for failover. In active standby, the standby server will be idle until something goes wrong and it will take over. Okay. Okay, so question is, so does it mean camera recording directly on the VMS server will require additional license per camera? Yes. So vendor will also charge you licenses for failover. That's why I said capacity 300. So yeah, this is something you need to understand. This capacity 300 means you have licensed it for 300. All right, and you are recording only 150. So if fails over, it should have the failover license available to take it. Okay, so this is how failover works. That's why N plus 1 is used because when you do um, okay, let's say you have all 300 cameras. Failover requires license, right? So when you use N plus 1 failover, total license required will be sum sum of this plus the failover can handle another 300. So total license would be 1800 plus 300, 2100. If you do n plus n, that means for every server you're giving one failover, then you need double the license. So generally, the chances of one server failing at a time may be there, but more than that is very less. That's why most of the designs are n plus 1. And also it's the most cost-effective design for a failover. Okay, the failover license, some of them may have uh, a different model number. Some of them may require the same model number of the license. Okay, all right. Now, if the recorder is NVR, Just remember, just remember, there are two types of recorder. One was the NVR, channel-based NVR. These are embedded, no camera license. These are actually, you buy a proprietary hardware, right? These are pre-designed, pre-built hardware from the vendor. When you're buying a recorder from the vendor, they already pre-license it. You don't have to buy any license. So when you buy a failover server, it is also pre-licensed. All right. So when you have failover in NVR, it's okay. But if you buy your own server, HP server, Dell server, and you buy VMS license for the recording, and then you have a failover HP server or Dell server, and you buy, then you have to buy failover license. So you have to keep in mind, generally, when you're buying a purpose-built server from the vendor itself, it's mostly built-in license. So even for failover, you'll buy the same server from the vendor. It will also have built-in license. If you're making your own server, then it would be license based. Okay. And the purpose built vendor can supply either Linux based or Windows based recording servers. Okay. It's up to the vendors, uh, model list available or product lineup. Right. So, okay, there are some good questions. For live view and video wall, the display bandwidth comes directly from the camera or it comes from the NVR. Okay, for the video wall, it comes from the VMS server. Yes, there are some brands, they directly speak to the camera. That option is also there. Actually speaking, the answer for that question is dependent on the brand of VMS and their architecture, how they have designed it. All right. Most of them, they will take it directly from the VMS server because that's the most convenient way of authenticating and pulling the streams. All right. Then there are some who also take directly from the cameras itself. So we have both options in our video wall concept. So you have to just double check with the brand how they want to take the live bandwidth. And also cameras, it's a edge device, right? If you ask too many streams from the camera will say, I don't have that much resource. So it will say, ask my switch, ask the switch, or ask the server. So that is also a reason. So why some vendors use VMS to be the point of contact for all the clients, decoders, right? So that has to be checked. Okay, yeah, so next question, standby or failover recorder, should it be the same capacity as the main storage? It is entirely up to the project design. Some of them will have failover for standby for 3 days recording. Some of them will have for 7 days recording. Some of them may have for full 30 days recording. What is meant by N plus N? Okay, N plus N means if you have 6 servers, you need another 6 servers for failover. That is N plus N. Is PRN NVR model can I have 1:1 redundancy? 1:1. NVRs generally support N plus 1 alone, and you can make your own option. You can buy if you want 1:1, it's like N is to N. You can do that also. Um, can be done. If active and standby fail, I did not get the question. Okay, can we take 90% load on all server and use 10%? Actually, sorry, I did not get that question fully. All right. Okay, so we saw in VMS, you can also integrate to third-party system. For example, access control. If someone opens the door, you can have a pop-up with the photo of the person from the access control and what was the event, access was granted or denied. You can unlock the door and so on from the VMS. You can map camera and door icon in the same map from the VMS. So it's called unified mapping, right? And we saw these yesterday, reporting, integration, alarm events, general monitoring of different cameras from different NVRs. Next is RAID. We will see RAID and what is the idea of RAID. RAID is a redundant array of independent disks. Redundant array of independent disks. Okay. Uh, the word itself explains quite a bit. First, if you see from the left side, let me write it down. Redundant array of independent disks. First thing, independent disk. When you have a recorder with 10 hard disk, if one of the hard disk fails, for sure, whatever data is in the hard disk is gone. Maybe there is a recording for 5 days. It will be gone. Okay. That is your independent disk recording. Next comes the idea array of independent disks and redundancy in that array. Okay. So those 10 hard disks, you can group it, right? And you can, and that's called an array. Then redundancy. Redundancy means within that array, any one hard disk fails or two hard disk fails, still you should be able to recover whatever you have lost. All right. Okay. So here we go. Let's take the example. RAID, let's say HDD1, and you have 10 hard disk. Let's say each of them is 1 terabyte. If one of the hard disk has failed, you have lost the data for that hard disk. Okay. Now, in order to uh, safeguard the data, what would generally people think? All right, they would think, all right, I need to keep another duplicate of the same data. That means from the camera, I will record twice. I will record in NVR1 and I will also record in NVR2. Same data, right? So this there is another word for this. This is called mirroring. Whatever data you have in NVR1 is again duplicated in NVR2. However, this kind of solution will be is actually expensive for two reasons. One, when you have projects with 1000 terabyte storage, you cannot expect an end user to invest another 1000 terabyte just to safeguard his data. Okay, and the chances of a hard disk failing, I mean, when you give a duplicate of 1000 terabyte, you're saying the entire set of hard disk can fail and you have a duplicate. That kind of disaster is actually extremely rare. You cannot expect in most cases the entire set of 1000 terabyte to fail. All right. Maybe one of the hard disk due to life can expire after 3 or 5 years, or maybe two at a time may fail, right? At any one point, either one or two hard disks can fail. Okay, so that's why there is another set of I mean that's why there is this RAID concept called RAID 5, RAID 6. We will see that. Okay, this mirroring concept is called RAID 1. If you do a mirroring of the same data, duplicate on other set of hard disk, RAID 1. When you apply the principle, there is a chance any one HDD can fail and I need to recover only that failed HDD. Okay. Okay. So this is RAID 5. In RAID 5, out of this 10, any one may fail. You will put a brand new HDDX and it will recover the data as if nothing was lost, as if the recording was never missing, right? It will fill it up. This is RAID 5. What is RAID 6? In RAID 6, you are assuming there is a chance that any two hard disks may fail at a time. At the same time, or just within a few seconds, any two hard disks can fail, and you are replacing uh, two new, brand new hard disks, and still all the lost data will be recovered as if you lost nothing. All right. RAID 6 is better than RAID 5, of course, right? Because you have allowance or tolerance for up to two hard disk failure. All right. Now, so far that is good. How RAID works, we can see later on after the break once time permits. Before we close, there is one more point on the RAID part before we close for the first break. Um, any one can fail, right? Any one of what? Here I have 10 hard disk. What if I have an NVR with 20 hard disk? What if I have a project with 100 hard disk? So you have to create a group. You cannot say out of 100 one can fail. There is no way. Maybe out of 100 maybe two can fail at a time. So that's why there is the word array. Array size. You have to specify out of what level, out of how many in a group. So here out of 10, my array size is 10. So that means 1 out of 10 HDD may fail and I need to recover. So you have to have a good ratio. So out of 10, 1 can fail. Okay, if you have a project out of 100, that means this is not a good RAID design. Many reputed vendors will not allow that level of RAID. They will probably keep 8 is to 1, maybe 16 is to 1. That is okay, but more than that is actually a bad design. All right. All right. So, okay. So out of 10, any one hard disk can fail, right? So this one, any one, it can be 7 or it can be 5 or it can be 8 or 10. It can be anything. So whenever you use RAID 5, um, for the RAID 5 to work, RAID 5 will keep some extra reference data. Okay, reference data. What is reference data? A simple way to understand is 1 plus 1, okay, 1 plus 1 equals 2. If I have 1 on hard disk 1 and other data 1 on hard disk 2 and 2 is on hard disk 3. If I lost hard disk 2 and I insert a brand new hard disk X, okay, brand X. So what is X? X is equal to 2 minus 1. So it gives me answer 1, right? It's actually 2 minus 1, that's your 1. So in order to rebuild the data, you need some reference. So whenever any hard disk is lost, it has to rebuild the data. So for that, it requires some reference. So that reference data will take some storage space. So whenever you buy a RAID array or whenever you build a RAID array of 10 hard disk, each of 1 terabyte, although total is 10, you will only have, you or you can use only 9 TB. Okay. This is called raw storage. 9 TB is called usable storage. Whenever you go and look for any RAID storage system, you will find this word raw storage and usable storage. Raw means it's Now, all the data, all the hard disk, total hard disk size is raw, but after configuring RAID, what will be the usable? Subtracting the reference data. Reference data is also called as parity bits. In the RAID world, it's called parity bits. All right. What about RAID 6? RAID 6 will keep two reference data. So if you use RAID 6, it will take the hard disk size of 2, so you will have only 8 TB. Okay. So just because it's 1 TB, it may not look much, but if you have 10 TB each, you will have only 80 TB. All right. So RAID 5, RAID 6 will give you lesser usable data. For critical infrastructure projects, RAID 6 is good. For general projects where you have a good maintenance system in place, where you can replace things within 24 hours, you have spare hard disk on this field, you can go with RAID 5. As long as you use a RAID controller, both of them, it's almost the same in terms of performance. Okay. There are two types of RAID, software and hardware. Software is no longer used, but you should use a hardware RAID. Hardware RAID means there is a, just like your graphics card, you have a RAID controller which manages the hard disk for RAID. So that's the best. So you may check, but most of them today are using hardware RAID. All right, let's take a break and we'll be back. And if there are any questions, you can post and we'll answer them immediately after the break. The next topic for today is about control room monitors, how to estimate the control room monitors. Okay, right. Other questions on RAID, we will take it after this topic. And also I will show you after the session how to use the Toolbox Plus for calculating a RAID-based storage system. This one, RAID, it is ideal that you use a vendor's calculator or ask the supplier's calculator because the RAID function is actually dependent on the ratio used by the vendor. Some of them may use 8 is to 1, some of them may use 10 is to 1. So it can change. The thumb rule is usually 25% spare for RAID. You need extra storage for the RAID reference data or parity. Okay, so that's the thumb rule. We will see about this and the after we finish the video wall consideration. Okay, so first control room monitors. How do you decide how many monitors are required for your project? How many monitors are required for your project? Once you have an idea on the number of cameras that a project has, it could be 500 cameras, you have to create a category of critical cameras, main entrances, all the identification purposes cameras are critical, right? So they come under the critical percentage. Critical cameras means you need an operator to look at it, look at those cameras all the time, okay? And he should be aware of, or he should be looking at it to identify any issue, any threat, any incident, like storage tanks, petrol tanks, reception desks, storerooms. These are all critical cameras. You have to keep cameras on the screen. Why do we need this estimate in the first place? Okay, why am I even talking about this? Control room monitors. How do you decide the number of monitors in the control room? Again, you can have as many monitors as you want, but that will not be possible when you have a project in hand. The control room may be smaller. The number of monitors, if you have more, can increase the cost. So budget may be an issue. So you need to have just like in camera, minimum you should do detection, right? Same way, there should be a minimum number of monitors for a specific project for the best operation purpose. Okay, so we are going to calculate what is the minimum number of monitors that is suitable for a typical project. Okay, this may not be applicable for perimeter security where maybe you need to see all the areas all the time, but this is for general projects where you have critical areas and less critical areas. None of them is not it's not non-critical. Everything is important. There is highly critical areas, high priority cameras, and less or medium priority. Okay, what is this remaining priority? Remaining priority is your waiting areas, or could be corridors, or it could be certain staircases. Maybe, you know, you only if there is a per usage, you need to know about who is in that area. All right, so they can come under lesser critical cameras. Okay. So let's say thumb rule is around 15%. Let's say 15% of your project, all the ground floor is actually critical, by the way. Roughly speaking, all the ground floor is critical cameras. Roughly 15% of your cameras are critical, and maybe utility and lift cameras are critical. So 15% of your project is critical, 75 cameras, that is out of 500. The remaining is 425. All right, done. Now in your control room, you can see the monitor in 2 by 2, you can see in 3 by 3, or you can see 4 by 4, or you can see uh, these cameras. Okay, that's fine. Or you can see in 5 by 5. All right, you can still see all the cameras quite okay. We can put few cameras here. Okay, the more higher the density you go, the lesser the or more strain for the operator to make any identify any difference or any intrusion in the scene. Okay, if it is all different rooms, maybe one is roof, other is staircase, other is parking area. If it is all different scene, different scene altogether, it will be difficult for the operator to identify any incident. So ideally, this whatever the operator is looking at, this scene, if it is all similar, then his ability to detect an intrusion will be good. Maybe all of them are parking entrances, all of them are main entrances, lift entrances. Then the operator will have certain ease in identifying an incident. Okay, then 3 by 3. 3 by 3, if you have few cameras, good, but when you have large projects, 3 by 3 can become an expensive because you need more monitors. So generally speaking, 4 by 4 or 5 by 5 is commonly used. So let's say I am going to keep all the critical cameras fixed. There will not be any change. No one will change the view. It will always be on the monitor. Let's say 4 by 4. Okay, if I keep 4 by 4 at a time, I can see 16 camera. So total monitors required will be 75 divided by 16. So I need 5 monitors permanently fixed. Then the remaining cameras, I can do a feature called sequence. Sequence, we saw yesterday what is sequence. So sequence is a group of cameras switching every 10 seconds. It will show this for 10 seconds. After that, it will show the remaining 10 cameras, right? So it's changing the layout to another 10 cameras. And after 10 seconds, again, it will go back to other set of cameras. So when you have lots of staircases, you can probably put all of them as one group. All the staircases, all the back door, back lobby areas, anywhere you already have access control for the person to come inside. It's a little bit more secure and things like that. Then you can keep it under your less critical areas. Okay, so I am doing a sequence of 5 by 5. Every time it changes, every time I can see 25 cameras. So within 1 minute, okay, every 10 seconds. So within 1 minute, it's 60 seconds. So I can see 6 times 25 cameras. So total 6 into 25 is 150 cameras. So you got this point. At a time, I'm seeing 25. After 10 seconds, I'm seeing another 25. So within 1 minute, there are 60 seconds. So within 60 seconds, I will see 6 times 25. That is 150 cameras. Okay, so the remaining number of monitors will be less critical divided by 150. That will give you 3. So total monitors required is 8. Okay, this is the minimum level. You can have additional 1 or 2 monitors for the operators to take video export, to check, you know, to do functions like this, to check the dashboard, or you can have a separate monitor for events. Only if there is an event, it will pop up, or for doing investigation and search and playing back. Okay, what happened this time? Who was here, and so on. If you want to do this level of detail, you need to keep a separate monitor for this or a PC for this, where you do export, where you do spot investigation, um, and also probably you have alarms that you want to verify, you can do that. Okay, so you can keep additional 1 or 2 monitors for that purpose. All right, so how will your video wall look in this case? Okay, so total 8 monitors. For this image, I need 5 monitors for fixed view. Okay, so let's say I don't have budget for 8 monitors, then I can go to, I can make fixed view as 5 by 5. Then I need total 6. Okay, in this case, 5 by 5 fixed view, 3 monitors. On the top, all of them are sequencing. Why 1 minute? Let's say the operator decides at any point what's going on in the staircase area. So he will look at one of the monitor with all the staircases. Within 1 minute, that camera will come up. So he'll be fine. Okay, I saw some no issue, no incident. He'll go back to the other view. All right. So if you keep sequencing for 10 minutes, then he has to keep looking at the screen for 10 minutes. So that is not right. That will not work out. So that's why they keep, you can keep as low as you want, but generally speaking, within 1 minute, you should identify an incident. Okay. The next point, excuse me. When you have a large number of monitors on your project, you need a video wall solution. Because just like NVR, when you have too many NVR, too many camera, you need VMS. Same way, when you have too many monitors, let's say 16 monitors in this project, 4 monitors, 16 monitors, then it's good if you have one video wall manager, which will control what cameras will be displayed, what layout will be displayed on each monitor. Otherwise, if you don't have, you have to go, you will have 12 keyboards, 12 mouse. You need to go to that specific keyboard mouse, or you have to have another hardware to manage all this. So it can be good if you have a video wall based application for when you have a lot of monitors in the project. Also, video wall allows you to merge monitors. You can have one camera across 4 monitors. Otherwise, it will be 1, 2, 3, 4, 5, 6, total 6 monitor. But I can merge one camera across 4 monitors. Also, a benefit in this case because you can see a 4K and a big screen, or maybe this is the critical monitor that you want everyone in the control room to see. It may be useful. Again, very rarely used. If you put it on one screen also is more than enough, but these kind of features may be possible. Another option, video wall can be supplied by the CCTV vendor, but most of the time it will be, in that case, it will be related to CCTV. There are also third-party vendors who supply video wall, where you can, in the control room, you can use that video wall to connect other system, maybe access controls, PMS, fire alarm, everything in one single video wall. That can be possible. But just remember that is good, but you will make it extremely difficult for the operator. The operator should also be trained on one more application, one more video wall software to operate, to learn the interface, to be trained. So you make it difficult. So you should also make it easier. So apply it wisely. Other considerations are uh, critical areas. You need operators to look at it all the time. So whereas the non-critical areas, the amount of stress or the effort by the operator is lesser. So if the operator is looking at critical areas, it's good to have a backup operator to do the task. All right, this is just based on certain surveys where the higher the number of monitors the operator is looking at, the lower his capability to detect any incident, higher the monitors. Okay. Then generally for an operator, how many camera scenes or how many scenes that can be assigned to one operator? Let's say in a scene, the operator detects an incident and it takes him 2 seconds. And after he detects, he will identify whether it is really an incident. It will take another 2 seconds. Then for him to call the emergency or call someone to response to create an incident can take another 20 seconds. And then with he has to take all the okay, that takes around 20 seconds. So totally for the incident, it took him 24 seconds. Ideally, you should make the decision, all the decision whether everything is okay or not within 60 seconds, right? So how many scenes can he see? This is actually a formula. If this is the capability of the operator, some operator, new operator, they need more time, but generally this guy can see up to 10 scenes. Okay? Maybe 10, a scene can have 4 camera, 5 camera, but it's 10 scenes. Now, if you use analytics, the detection is done by the camera itself. So you reduce the that time. In that case, he can see up to 20 scenes. All right, you see 2-second difference can actually double his capability to monitor. All right. Okay. The decision making, if it is 60 seconds, it's fine. But there are certain main entrances. What if there is an armed robbery, main entrances? He has to decide quickly. He cannot wait for 1 minute. In those kind of situation, you should limit the number of scenes that the operator is monitoring. See, most of the time you have security guards on the entrance itself, near the entrance itself. So you are having a backup. So it's fine. But if you don't have, then just keep in mind that how fast you want him to react to an incident will determine how many scenes he can monitor at the same time. Okay, all right. Okay, you can read about this. Basically, a scene I already explained. It should be visually coherent. It should be similar scene, not be different scenes, different buildings, different location. That not to make it complicated. And it in the monitor you should group in an intelligent way, not no, I mean entrance one, then entrance two. It should not be entrance seven, eight like that. It makes it difficult for the operator. Then for the operator, there is a vision, right? Just like you, when you look in front of your screen, that's your main area. It's called peripheral vision, near peripheral. In near peripheral is where you can quickly identify any incident. If it is side, it's called mid peripheral. uh, it will require for you to slightly move your eyes to see if something happened. In far peripheral, you have to move your head to see if something has happened. So in far peripheral, if you keep critical monitors, for sure it should be associated with analytics. So it will create a sound. Then he will turn his head and see. So critical monitors should be within this near and mid peripheral area. Okay, and another common question is what should be the resolution of the monitor? Um, okay, resolution of the monitor. Now, when you use a 42-inch 2 megapixel monitor versus 42-inch 4K monitor, the pixel, let's say this is 42-inch 4K means how many pixels? Okay, first we have to look at the slide. If it is a 4K monitor, the horizontal pixel is 3840. Horizontal pixel for full HD is 1920. 1920 by 1080. You know this. Okay, more pixels. When you have a 42-inch monitor, full HD, the size of the monitor is already fixed, right? 42 inch. If you have full HD, the difference, pixel 1, pixel 2, there is a gap in between. You can see the gap. But if you have in the same 42 inch, maybe 3000 pixels, you're doubling or tripling or making it 4 times more pixels. Now you cannot see the difference. You cannot see the gap, right? So this is why whenever you have higher resolution monitors, well, that's why it's not yet very commonly used in control room, the viewing distance will be reduced. You have to go closer to see. When you have a 4K monitor in 42 inch, you have to be actually less than 1 meter in front of the monitor to see what's going on. Makes it difficult to differentiate between pixels, differentiate between an incident and a non-incident. All right. That's why higher the resolution, more the closer the distance. Closer the distance is difficult because too much strain on the eye and he cannot see more monitors. That's why still full HD is quite commonly used. All right, I hope you got the idea. So far from the monitor, he can see more monitors, right? It's like this monitor is staring at your face. This one, you will have enough view to sit back and relax and see the, there can be some distance. If this is very close, it can be painful. However, if that's the only option, you have to follow these guidelines, best practices to achieve the best distance and viewing distance. So you can always approach a control room, you know, furniture manufacturer, right? There are many reputed brands. They do ergonomic design. They can consider all these for you when they do the design. So that's why it is okay to approach such vendors when you have a control room design requirement. All right. In today's networking topic, we will speak about the OSI model, the TCP IP layer model, layer 1, layer 2 switches, layer 3 switches, and other CCTV concepts. So in today's topic on the OSI layer and the TCP IP layer, these basically are protocols or rules that govern the exchange of communication between devices, okay, in any network. Um, Example, it could be you listening to this broadcast. It's a form of communication. There's a video, there's audio being transported from my location to your location, right? And in order to achieve that, there is a certain set of rules, protocols that happen at the back end. And they follow either the OSA or TCP/IP. And today we will focus, or we need to understand TCP/IP is more relevant for us to understand. Okay. In this layer, we will compare both simultaneously and explain the application layer in the TCP/IP model is similar to application plus presentation plus session in the OSI model. Simply, um, the webinar platform, that is your application layer. It is sending or streaming video as well as streaming audio at the same time. Now, this particular data has to be sent over the internet, right? And it cannot be sent as it is. It has to be broken down into smaller bits, ones and zeros. So that is your transportation layer, where each of the data is broken down into smaller bytes, and it will have a destination, where to reach, where to go. So from my PC, it has to go to multiple destinations, each of your computer. So that is your internet layer, where each of you have an IP address. So my packet has been is been I mean it's been it you can say posted to different IP addresses. It's like I'm packaging my um, video and audio in the transport layer and then sending it out to you and to each of your IP address. Okay. How are you receiving it? You're receiving it via wireless adapter, that is your Wi-Fi adapter, or if you have direct cable connected, that particular port, that Ethernet port, that's where you're receiving it. So that's your network access layer. And then if you're using wired communication, that's the physical layer, that the cable that you use to connect to internet is your physical layer. All right. So this is the summary of the OSI model or the TCP IP model. Okay. So the physical layer is your physical cable, which you are very commonly aware of or you're using. That's your Ethernet cable that you see. So the first related topic to this is the Ethernet cable. We will study that in a bit more detail. This is cable. This cable is what is commonly used to connect a camera to the network switch, right? Sometimes the Ethernet cable, you would hear from the customer saying Cat 5, Cat 6, right? So that is a category for the Ethernet cable. Higher the category, higher the speed. Or for example, Cat 5 can handle 100 Mbps, Cat 5e, Cat 6 can handle 1 gig, and so on. So higher the throughput or bandwidth that it can handle. So this cat Ethernet cable, or we will going forward refer to as Cat6. So the cables, they have different cores, 8 wires. Okay, each wire has a function, right? Um, Ethernet cable does what? It tries to exchange information. There is data being sent and the data being received. Videos being sent to the recorder, and some settings are received back from the recorder or from the client. So there is a two-direction communication or bidirectional communication, right? So each wire is like a communication pathway. So if if the first two wires are sending data, the next two wires will be receiving data, plus and minus. Okay, plus and minus transmission, TX, plus and minus receiving. Okay, then the other wires, what are their purpose for? Now, if we use more wires to send data, you can achieve more bandwidth. So that is what Cat6 does. You will find Cat6 using all 8 cores or 8 lanes for sending and receiving data, whereas Cat5 will only use 4 wires. So Cat6 has more bandwidth. So that is one. Next is in the CCTV, especially cameras need power. It's a small computer, it's a small device that requires power. So what we use is to send power over the same data cable. So that is referred to as power over Ethernet cable. So it is doing two functions. The Ethernet cable now is exchanging data as well as powering the camera. Where is it powered? So it is sent over these cores. Then the power consumption of a camera can vary. Camera 1, maybe outdoor, can take more power than camera 2, which is probably indoor inside a storeroom and requires less power. Why does outdoor camera require more power? Because it has a heater function, it has some IR LEDs and so on. Then there are there is one more type of camera called pan tilt zoom camera. They have a motor to move the camera itself left and right and zoom. They need even more power, right? Maybe more than 60 watts. So how do you categorize a PoE? Standard PoE, right? Then PoE plus. PoE plus is 30 watts. Standard PoE is 15 watts, 15.4. Then high PoE. High PoE is beyond PoE plus, you would refer to as high PoE. Okay. So you can find here PoE 15, PoE plus, above 15 and up to 30 watts. Above 30 is called high PoE, HPoE. Okay. Now all of them does the same function, that is inject power over the Ethernet cable. All right. Why do you categorize it? Because more the power, the more heat dissipation required, the more the equipments need to be designed. So the price of the device or the installation can be higher. The switch device can cost higher depending on the capability. If a switch can so camera connected to the switch. If the switch is PoE plus, maybe it's more expensive than a camera connected to a standard switch, which is PoE. So there is a difference in this. All right. Now I will take one data sheet and explain and show you the difference between the cameras and their power consumption. So I have here the data sheets open. It's actually a comparison catalog, so you can see cameras side by side. All right, so let's take this first and second. First one is outdoor camera. Second one is also partially outdoor. All right. So both of them, you can see the power consumption 12.95 watts. So it is a standard PoE. Let's say if there is a PoE plus. Okay, there are cameras which are PoE plus. So this one is a bullet camera, which takes roughly maximum 20 watts, above 15, so it comes under the category of PoE plus. Okay, then let's take PTZ. So the PTZ cameras, they are capable of rotating the camera body itself. So there is extra motor attached to it. They need more than 30. They come under HPOE, high POE. All right. So what else? We have here XNP6320. There are PTZs which only take PoE plus, and which means less than 30 watts. However, there may be a condition mentioned. Um, Heater should be turned off. Okay, so you can check that in the data sheets. Without heater, it can work with PoE plus. So you don't have to jump to high PoE, injectors or devices. All right. Next is transmission. Again, in the physical layer, where in the transmission side, if your camera is at a very far distance from the nearest switch, in that case, you have to convert that Ethernet cable into a fiber medium. Why? Greater distance. Ethernet cable, they have a limitation of 90 to 100 meters. But if you need to go more than 100 meters, of course, there are projects where 100 meters is not applicable. City surveillance, large government property, shopping malls, most likely you will end up having locations where you need to convert. So these are called media converters. The medium of transmission, you convert it, it's called a media conversion. So Ethernet, you're converting it to fiber, and then you can receive it back, and basically you encode it into fiber medium, and then you decode it and send it back as Ethernet to the switch. That is one. There are switches, small switches available. They take Ethernet and they have fiber. So from here directly you connect to a fiber switch instead of another standard switches, Ethernet switches, you connect to fiber switches. So that is one more option available. Okay, but for the sake of simplicity, let's take it as a simple example. If your cameras need to be transferred over fiber, you will need a converter, media converter, to convert Ethernet to fiber. Why? Again, one more reason, not just distance, the camera itself may not have, most of them actually will not have a direct fiber connection. You will have to take Cat6 Ethernet and then convert it. There are very few cameras, they have direct fiber connection. So if I take, for example, in Hanwha, certain PTZ models, certain panoramic camera models, there is an adapter which you connect at the back, which converts the camera into fiber. These cameras are meant for city surveillance installations, so they come with that option of directly converting from the camera side. So you don't need to buy a separate converter or adapter. Okay, so that is one possibility. Then for retrofit installations, you have old analog cameras and they use analog cables. If you have to, let's say BNC cable, so these are old analog CCTV cameras and the cables look like this. Old televisions when we had, it used to have these cables. So they use a BNC connector. Now, there are projects where these cables are already installed and you need IP cameras. Then there are solutions where the Ethernet can be again converted as a media conversion. You convert it to coaxial cable. So you use a converter and the same data is transmitted over coax and you have to receive it back and then convert, basically you have to translate it back to Ethernet and then send it to the switch. So you got the idea. So that is also possible. Definitely it is useful for locations where there is no other way to pull a Cat6, unable to pull Cat6. So in those places you can use media converters to use whatever medium is available and then transmit back. Okay. So you can say it's like a translator. So let's say if you are speaking to someone from a different country and he doesn't know your language, you have a translator. So you translate it, he will again listen to you in your language and translate to the person in his language. So it's like a media converter. Layer 2, Layer 3 are common words used in CCTV, such as Layer 2 switch, Layer 3 switch, and so on. We will directly jump into the key difference and where you need a Layer 3 and Layer 2. Okay, let's say here I have five computers. They have to speak with each other. They are all in the same location. Maybe it's a training center, and the five computers are in the same network. Okay, and in this case, I will use a switch to interconnect the devices, and they all belong to the same network, a local network called LAN, local area network. All right. There is no outside communication, neither is my computer required to speak to another computer, maybe somewhere in a different branch office. There is no communication like that. It's a very basic communication. There is a switch, and all my computers are connected to the switch, and they speak with each other. That's it. There is no internet, there is no external communication. All right. So a layer to switch typically uses MAC address. I will use this opportunity to explain what is MAC address. MAC address is a physical hardware ID. So every network device has a physical unique ID called MAC address. It's like a physical address. Your IP address can change, but MAC address don't change. It's like a fingerprint of a device, network device. Okay. Layer 2 switch uses MAC addresses for identifying where the devices are and communicating with them on that level. Now, on MAC address part, when you go to command prompt and type in the command ipconfig slash all, you will find the MAC address for your device. It's called as the physical address, right? So you will find it here. Next, where do you need layer 3? Layer 3 is if you have different networks and you want to speak to a network outside your office. Let's say my training room computers need to speak to a corporate network. It has to be connected to another training center somewhere else. So in that case, I will need another device, a routing device, right? A routing device. So this is a layer 3. Whenever you need routing function to communicate between two networks, you need a router. Example, if your CCTV system has to speak to uh, access control system, you might have a router in between. If your CCTV system has to speak with the operators which are on the corporate network, let's say a bank, they have a CCTV network, and then they have the staff, they have their own network. If you have to route between these, you need a layer 3 switch in between. Or if you want to connect to internet, you want to say remotely, you need to have a router in between. So basically interconnecting between different local networks, you need a layer 3 switch. Now there may be another reason why you need layer 3 switch is virtual LAN. Okay, a switch has got, let's say here, 24 ports or 48 ports. Now you might have let's say okay, let's take this example, and let's say within a switch I have five devices connected. Now every time device 1 wants to speak to device 4, it will send uh, to the switch saying, I want to speak to device 4, and that IP address is 14. So switch will send a broadcast out and check who is device 14. All of them will reply back and say, uh, I am not. Only the 14th device will say, I am device 14. All right. So every time there is a request sent, it is broadcasting and figuring out where the device is. Okay. To avoid this process, there is another table the switch keeps. It keeps in its memory who is 14, and it also keeps in its memory what is its MAC address and so on. But generally speaking, the switch is now open to all the devices. Device 1 can see every other device. Now imagine in a network port, there are 48 ports. That's like 48 devices, right? And every device has access to other devices. Maybe let's say you want to uh, group them into smaller LANs. For example, the first 10 cameras are belonging to first floor. The next 10 cameras belong to second floor, right? So if you want to group them, you create a virtual separation. Okay, although they are in the same network, same LAN, you split them. You, okay, to a virtual LAN that is called smaller groups. Okay, so this is also referred to as virtual VLAN. Okay, so what does this do? This breaks the network into smaller groups. So every uh, virtual LAN group 1 will not have access to virtual LAN group 2. From virtual LAN group 1, if I try to connect to a, a device in LAN group 2, it will not communicate because it is virtually separated. If you want to speak, then on demand you can. For that, you will need again a layer 3 device, because what is the objective of layer 3? Layer 3 is the one responsible for routing. So the layer 3 switch can also be used for routing traffic between VLANs. Okay, so that is possible. Maybe you have just one security network. Okay, CCTV access control, maybe fire alarm system, intercom system. You can split them into different VLANs. Sometimes customers do that. So CCTV system cannot access control system. So this is one way of splitting your local network. But they all fall under security network. Under security network, you have CCTV network, you have ANPR network, you have access control network, you have intercom network, right? All separated by VLAN. Right? This avoids traffic being sent everywhere else, and also the quality of connection improves greatly when you use VLANs. All right, so that brings us to the end of today's session and also the end of 4-day video foundation course. And today also I will be setting you a quiz link. Now, just some guidelines. Once you finish the quiz, you have just give us some time. It will take up to 30 days before we collect all the results, check all the results. We will check your attendance, because attendance is also mandatory. We will check everything, and then we will put forward um, whoever is certified and so on, and then we will issue the certificate within 30 days.